Great. Hi, I'm Hubert. Welcome to another edition of Demo Days. Today, we are going to ingest IoT data into Rockset, and we're going to do it through decodable so that we can prepare that data before it gets to Rockset. If you're not familiar with Rockset, it is an analytical database for real-time, low latency queries. A lot of these types of databases really benefit from pre-processed, prepared data that's already flat, so that those systems or databases can really focus on that really low latency queries, and not spending too much time transforming and cleansing that data to get it to be presentable to the dashboard. In this case, what we'll be using is Superset. So this is the flow we're going to build or kind of walk through. Here's kind of more colorful version of that. What's happening here is that we're going to use, well, I'm using my phone. I've been, have had this set up for about a little over a week now. So I've been accumulating data from my phone for the past week and a half. So we're using an app called OwnTracks. It's something that you could download for both Android and iOS. And that will be sending to a cloud MQTT provider. In this case, it's actually called Cloud MQTT. Others that you could use could be HiveMQ, and a lot of the corresponding cloud providers also provide their own MQTT brokers that you could use. But the kind of the path is that you have a phone app, you put the connection information to your cloud MQTT provider, it starts sending those metrics to that cloud MQTT broker. MQTT is just a protocol, a really lightweight protocol that allows you to send data to an MQTT broker that where the connection may be really spotty. For example, let's say you have like a furnace that's IoT enabled. It's probably in your basement, and your Wi-Fi is somewhere else, maybe the second floor of your house. It's not going to be able to send in a like reliable connection, right? So MQTT really allows that. You know, it could be in your car, you might be in the mountains or in the middle of the desert somewhere. That's, you know, those are spotty connections. Also, they do this with like airplanes. You know, if you're out up in the sky somewhere, you're also able to send MQTT messages with spotty connections, right? That's really the intention of what that protocol does is. So what we're going to do is capture that MQTT or iOS data from the cloud MQTT broker through Kinesis, and then we're going to process it through decodable, put it back into Kinesis so that Rockset can easily just grab it from Kinesis, right? Decodable is really just shimming itself into this this path so that it just makes everything easier downstream from where it is inserted. Okay. Just to give you an idea where you can find some of this stuff, OwnTracks. You can go to owntracks.org. Here's the blog. You can actually find it in your app store, and it kind of looks like this. It already knows where you are. I'm in North New York, northeast part of the country. And you could also use some other tools to navigate or kind of browse your broker, your MQTT broker in the cloud. Yeah, we'll actually walk through this in a second. So let's just get started here. First, you want to download this, obviously, and configure it on your phone. Next, I would recommend that you could use, let me find, I don't actually have that cloud. You can just log in with your um, social sign-on. So I'm just gonna use my, I don't actually have an account here, but we'll just do this from some scratch. Okay. So what you do is you create an instance. You want to create a free one. Tags like region. Let me just go to my own version of this so that it doesn't have to think about it too much. Here it is, actually. Great, let's just log in. Here's my account. You'll see some your information here. Other settings. If you have a secure connection, you can provide certificates and then provide some users if you want others to join. I added myself. If you want this use case to be used with some of your friends and families, you can add those users here. This also has a Kinesis integration. It can send all those messages directly to Amazon Kinesis. I'm kind of a cheapo. So I don't have the higher grade, upgraded account. So I don't have this feature. So what I'm going to do is create a bridge from the Mqtt broker and Kinesis. And that's what this is doing right here, the Mqtt client Python. It's a little Python application. It's really simple. If you want to look over it, you just create a .env file with all your credentials, including your AWS account and your Mqtt broker information. And all it's doing is the integration is really is right here. The onMessage function is what's causing what creates the bridge. So when a message comes in from the Mqtt broker, I create a little wrapper. Here's that payload. I'm preserving the topic and all this other information that we really don't need. I'm just going to dispose of, but it's all part of this object here message. And then I'm going to put that record into this configuration, this P, which is a producer to Kinesis, okay? And now the way we create Kinesis is really here. We use this Boto3. You give it the region. So I'm getting that in from the environment. I also have some information here. So there's my client and then the stream that I would like to connect to. It's a really easy application. I'm just looping for infinitely for more messages to come through from my phone, and those automatically get sent to Kinesis. So I built my own bridge, kind of just to save money, and that's what this is here. So I put a little bridge between Mqtt and the Kinesis stream. So what we're going to do is kind of go through configuration of the Kinesis stream accounts. Let me just get my credentials here. Oops. Yes. So. I'm not sure what happened there. So the first thing you need to do, and it kind of documents it in here, is to set up your IAM roles. Okay, so first I'll go to Kinesis. It's really easy to create a stream. All you just need to do is create a stream, enter the name of your stream, and then click create. It's really that easy. I already have 2 streams here. These correspond to the the streams that I'll be using in Decodable. This is the source, basically this stream right here, and then the sink, which is the stream right here. After after Decodable has completely configured it or prepared that data for Rockset. Okay, so you go to IAM, and all you'll need to do is create a role that has some of the requirements that the permissions that Decodable and actually Rockset also needs. So I have some things that I've already built in here. One's for Kinesis, one's for Rockset. So you create one, you want to choose the custom policy, and then you want to grab this policy down here. So you just copy paste it. I'm going to delete this policy after this video. Next, I want to use this Kinesis one. I've already configured it just to give you an idea what that looks like. It's this policy that you want to use here. It's this policy. Okay, actually, I'm actually doing this incorrect. Let me just go back previously. This is the trust policy. So you want this one in here. So copy that. That goes in here. And this account here is my Decodable account. So if we go to this page here, it's this name right there. Okay, so Decodable demo. That's what you paste in there. Okay, so this is the Decodables AWS IAM, and then this is the external ID. You can add actually multiple external IDs here corresponding to each one of your accounts in Decodable. Okay, and this Kinesis is you can edit this policy, but you just grab this content in here. It allows the permissions that you need for Kinesis to work. See the JSON view, copy, paste. It's already there. I'm not going to change that, but I am going to assign it to the role that I'm creating. Okay, so I create that. Let's Hubert demo day, and then click create role. Okay, so now I have a role that I could use, and this is the ARN that I want to use to configure my Decodable account. Okay, so let's go to Decodable and look at our connections. So that's what this is here. This source, this Kinesis Mqtt source. It parses data, so if you're sending it bad data, it is going to complain. It's a way for you to kind of monitor and watch the messages that you're sending to it, make sure that they're well formatted. If it's bad data, there are ways to kind of capture that. In this case, all I'm saying is that to ignoring any bad data. But in the details here, you can see that I'm using an IAM role. That's what this is. This happens to be a different one. I renamed it, but I'm using my old one here. And the format that I'm going to, the data is going to be inside Kinesis is going to be JSON. This is the region in which it lives, and this is the name of the stream that I'm using. If you recall, you go back to Kinesis. These are, sure it's taking me there. Oh, wait here. These are my, near my sync. This is the one I've configured to read from Mqtt source. That's this guy right there. Okay. So this is already running. Okay. and it's already writing to a stream. So the differences between connection streams and pipelines are this. Connections are able to bring data in and send data out of decodable, okay? And when it brings it in this case, it puts it somewhere. That data has to go somewhere. In this case, it's going to a stream. And here's that data that I've been sending. It looks like the data that I created in the bridge that I'm using between my MQTT broker in the cloud and Kinesis. I don't really care about these values, but I do care about the encoding JSON in the payload. This is just string right now. If you look at the schema, it's a topic, the payload is string, and so on. So how can I get this information out? And the only thing that really tells me who I am is this topic here that contains my name in it. This is the context own track. So you could have many contexts in your MQTT broker. In fact, let me do that. Let me show you how you can actually navigate. This is a free tool, open source tool called MQTT Explorer. You can disconnect from here. These are the credentials that you could use to grab this stuff from Cloud MQTT or whichever one you're using. And when you click in here in advanced, these are the subscriptions you would like to kind of find or navigate to. They basically, what I'm saying here is like, show me everything that's related to that application on my phone called own tracks, okay? And that hash symbol says, you know, everything below it as well. So let's go back and let's connect to it. Now I can see everything. I only have 2 users here. This is kind of a fake user, and this is myself. And this is my device ID. And here are all the messages that are coming through. Okay, so you can kind of validate your Cloud MQTT broker to make sure that it is capturing messages, right? And I have my phone here. I don't know if you're looking at me at all. I could just go into that app. And you should be able to see another record come in here. So I'll send one really quickly. And there it is. It shows you the difference between before and the new one and the old one, the previous value. And let's see, my velocity is 0. There's a lot of other things that you can learn from here. Oops. This is your, like the MAC address in your router. This is your router name right there, your latitude and longitude, battery status, which is, I think, I can't remember what one means. I'm at 66%. My altitude is this. My accuracy to some of this information is this. So you want to, if you want to get really precise with your numbers, you want to take into account some of these values here. And this is a timestamp right here. Velocity, I was going 38 miles an hour. I'm not sure how it thinks that. Some of these things are not very accurate. That's where you want to kind of account these accuracy numbers to the velocity and the altitude and so on. When you're displaying, I am not doing that, so you may get some funky numbers that don't make any sense. But let's continue on. So we're right here. We're looking at the raw IoT data, and I named that MQTT raw. We want to cleanse this data. We have that pipeline right here. So this is the next step in the pipeline. And this is how we cleanse this data. It's a bit complex, but when you walk through it, it's really not that complex. All I'm doing here is I'm selecting from that MQTT raw, and I'm grabbing the topic. Remember, the topic contains that really long string that looks like this thing right here, like the own tracks, Hubert, and this my device ID. I want to take my name out of that topic so that I can identify the user. So I'm just basically, all this is doing is taking their string Hubert out of that topic, so I know I can associate that user. And I'm grabbing this JSON value, is taking the payload and looking for this value inside of it. And then the outer function here is casting that value to an integer. And I'm assigning that value to a field called accuracy. Okay. So that's how we're going inside that payload. That is just string. This JSON value function here is going to parse that string, look at that field, pull it out, and this cast is going to cast it to a specific data type. And I'm expanding that name to have it be more descriptive, battery, level, and so on. Okay. There's a timestamp in here. If you recall, I'm using this timestamp to grab out of this field here. I'm casting it to this is a big is basically a long, and I'm multiplying it by 1,000 because this value here is actually a Unix timestamp, which is in seconds, and I need it in milliseconds to be able to use this function. So I'm making that milliseconds, and I'm creating a timestamp field. So that's all that's really doing. What's more interesting here is our case statement. I'm just doing fancy things here. They really don't make any sense, but it's really there here just to give you an idea of what you can do. I'm looking at the velocity that I've extracted from the JSON payload. I'm checking to see, the numbers. If I'm between 5 and 11, I might be running. If I'm between these values, I might be driving. Anything above that, I might be flying. If it's, the day of the week is between 1 and 7, basically Monday through Friday, I might be working. Else I'm resting, right? This doesn't make really any sense, but it's just a way for you to give it more enrichment in the when you're preparing this data. This is a formula for Euclidean distance. If you're not familiar with the Euclidean, it's like the Pythagorean theorem. It's like the x and squared plus y squared equals c squared thing. It's a way to figure out kind of a distance between one point and another. So this lat and lon right here, latitude and longitude, is where I currently am, extracted out from the JSON payload. And this here just happens to be where I live. These coordinates. So the outcome of this is really telling me how far I am from my house when I'm moving around, right? This could be anything. This actually could be a join from somewhere else. If you have a table of locations, maybe like I don't know, like the grocery store or whatever, you could actually throw up an alert that you are at that location based on a radius, right? If this radius is less than like 0.005, for instance, you can consider yourself at that location and then do a case statement here to identify. Just say, hey, I'm at the grocery store right now, and that's what I'm doing here, I believe, right? So what I'm doing here is when the user is Hubert, and I'm doing a Euclidean distance calculation, and if that value is less than 0.001, I must be really close to that place. And if that's true, then I must be home. If it's not true, then I must not be home. That's all that's doing. Okay. We can go in more detail. The one that I have inside the GitHub repository that goes along, that corresponds to this blog and demonstration. I think that the coordinates I gave here is the Empire State Building, so you can see yourself, how far you are from the Empire State Building. So if you continue on, that enriches the data, right? So I have a topic. I've kept that value, but now I know that it's me. The accuracy 7, altitude that. Here are my battery levels. my MAC address, my router. This is something that's confusing to me. I welcome you to go look that up. Has something to do with the curvature of the earth and so on. I'm not going to even deal with that. These are different connection values. If you look at this blog over here, it goes over which each value means. This W, I believe, means I'm connected to Wi-Fi. Latitude and longitude, the barometric metric pressure, my my Wi-Fi. This is how this event was triggered. This is just on a timer. If you notice the one down here, this is the manual trigger. I went to my phone and actually clicked the button, and that means the user actually invoked this event. A timestamp, a vertical accuracy, my velocity. Notice that this is not very accurate. I'm sitting, not really going anywhere. I shouldn't be going 30 kilometers per hour. So that therefore I think I'm driving. Here's my Euclidean distance, and I'm home. I must not be home if I'm driving, right? That's all this is. And I'm sending it to 2 different places. This is the one that we're going to be, actually this one that we care about. This is going back to Kinesis and sending that enriched data back to Kinesis, eventually to Rockset, right? So we just went through this entire path here to get to Kinesis and cleanse. So now we want to go to Rockset. Rockset, again, is a real-time analytical database for extremely fast queries. It's the UI. I love the UI. It's one of the better ones that I've seen. But basically, it's this. I can define a collection. Collections are what you would say are like what we say like tables in a database, right? And it's smart enough to know also if it's recognized some parsing errors. This must be some bad data going through the MQTT broker. If I look at it, so this is just a warning, and it's smart enough to kind of ignore some of that data if it's not good, so we can continue on. This is probably what's causing that error, this blank record here that somehow got to all the way to Rockset. So we have to maybe clean up our data a little bit more in decodable to omit those records. But here, notice that all those same information is provided here. But let's walk through how to create one really quickly. To create collection, these so many places you can grab this information from. Since we are real time, we want to be able to use something that provides real-time data, and this is streaming. So you want to go to use something like Kafka or Kinesis, and there are other ways to get this data too. Maybe if you want to be able to get some dimensional data, you can also show that information here and pull that into Rockset. Here we're concerned about Amazon Kinesis. I've already created it here, but let's create a new one. Kinesis demo. And likewise, what you've seen at Decodable, you have the same kind of configuration you have to do, okay? This actually is more precise in what it needs, what kind of actions it needs. We didn't do that for Decodable. But what we're going to do is cheat a little bit and use that same configuration for Rockset. So if you go back to your IAM, go back to your roles, Hubert. Notice I've already created one for Rockset. It's the same exact process. If you go in here and look at it, you see it's connected to the same Kinesis policy that I created earlier. So I don't have to recreate this. I'm just reusing it for Rockset. So you just grab this information here, and where was I? And you put that ARN down here. Okay. What you want to also do is grab the account ID and external ID. That information goes into your role when you're creating it. Let me go back to that guy. Rockset. It goes in here. Okay, you can edit this just like you did it for decodable. It looks exactly the same, but this is your ID here. I'll be recreating this again later. I'm deleting this policy. Okay, so that will get you connected to Rockset. Okay, like I said, I've already created one, and if I did use that, it'll show you. You just put your stream name in here, like you had in here. So in this case, I want to put, my sync. Sorry, Mqtt sync. So Mqtt sync here. The region that it's in, +2, the format. Now offset, you can start from the earliest or latest, it's up to you. Like I said, I've already have this set up. I don't want to build it again, but that's where we're getting our data, and that's why you're able to see it here. So let's, so now we have this picture almost to the end. We've gone through the own tracks, bridge, decodable, cleansing. We put it back into Kinesis, then Rockset, and now let's visualize some of this data through Apache superset. It's here. So this is my dashboard. You could set an auto refresh level or interval to kind of refresh every 10 seconds or whatnot. I'm just going to do it once. Not too much information here. Notice that this is like where when I'm working at my desk, it doesn't seem to think that I'm at rest. This is where I probably should be or adding or weighing in the accuracy component in the data set. Battery level obviously makes sense. It goes up in the beginning of the day, down at the end of the day, and so on. And this is a kind of a view. The higher it is, my battery level is pretty high, and this is where I live. Notice that when I'm home, usually I have really high battery power, so not very intuitive, but it correlates and makes sense to what I expect to see, right? As I pan out, my battery's high when I'm at home. This is a more interesting map. Let me go full screen here. These are my velocity levels. Like again, I'm at home here. I shouldn't be going this fast. And some of these are super high, so a lot of these aren't very accurate. In fact, when I get closer to home, it becomes less accurate. I think I have to be moving a lot faster to really get a good estimate of what my velocity is. And these are kind of the paths I've been driving in the past week and a half. This is obviously a road that I traveled down a lot, and I travel all the way up here to, let's say, Kingston or Woodstock up here, right? So how can you use this? IoT data, very good for, say, fleet management when you're trying to keeping track of your fleet vehicles. You want to know where they are, if you want to kind of monitor their speed, the temperatures, right? You'll be able to do some machine learning to see when these vehicles need servicing, right? Lots of information. If you want to kind of monitor your drivers, if your speed here is more accurate, if I took into account the accuracy, these numbers will be more accurate. You can see where they're speeding, where they may be unsafe. Talk to them and kind of help them not to speed a little bit. But yeah, so you could be alerted to a lot of these things. These and remember, it's not just all velocity. Let me just walk you through how to create a database in here. We already have a Rockset here. So all we need to do is click on a database. Here's some standard ones that they could use. Just type Rockset. This is the SQL Alchemy URL. Basically, you could look that up. You can actually just look at mine really quickly. This is a token that you need from Rockset. Let's do that. I forgot to do that. So in Rockset, you need to go to API keys. You need to create yourself an API key. I've already done that. And once you do that, so that's the value you would put in the beginning of the URL. And you click here to get your endpoint. So that's the back end. So you basically what you would do is go back here. It's just Rockset : / your token, and at the end append at and then paste this value in there. Okay, and then Superset will be able to find your data, or Rockset. So this is Rockset. You want to create a data set out of that. So create a data set. You can choose Rockset. Choose your schema, and then choose a table that you have. This is Mqtt Kinesis. You can add it here, and it'll create this thing right here. When you click on that, you start building a chart. You can use a table. I don't like this view. I'm going to click here, create a new chart. I'm going to select my data set, which is Mqtt Kinesis. I'm going to create a map. Let's do that same map that we were looking at. Chart. So your event time, that's accurate. You want to change your latitude, longitude. So that's lon lat. Let's see, bubble size. I think you want to choose a column here. Let's do velocity. Like the average velocity at that location. Let's take a look at that. So there's that. That same exact. Maybe that's why I didn't do it right. I need to take the average. I should go change that. Anyway, and that's it. This is data that I took from my phone that's being sent from my phone to a cloud MQTT broker. I bridged that to Kinesis and brought it into Decodable for transformation and enrichment, send it back to Kinesis into Rockset. Rockset provides really fast queries. And when you look at this dashboard, the reaction is really fast. If you were talking to some other database, you might not get this fast of a query time. And it only takes seconds to refresh each one of these. Each one of these is using the same data set that's being pulled in from Rockset. That's it. That was the full walkthrough of how to build this pipeline from end to end. Lots of fun doing this kind of stuff. This is, I guess, you know, when you do this, just know that this is all in kilometers. So I not going 400 miles an hour here, although that is still kind of high. But I've done this before where I was on a plane that was able to capture some of it because I didn't turn off my phone. and it saw me that I was going, that velocity really fast. I was in the mountains. I went on a boat even. And it all works. It's able to find me out in the middle of the ocean, and show me, my activities and how fast the boat was going. It's really cool stuff. I hope you enjoy the demo. If you have any questions or would like some help in building some of this stuff, we have a lot of people from the Rockset team online right now that are totally willing to help you out, as well as myself. Join us in our Decodable community Slack channel, and we'll absolutely help you out in building the similar solution. All right. Good luck and happy coding.